Find 3 resonance structures for the cyanate anion, OCN-, and make a reasonable prediction of the CO and CN bond orders for the hybrid structure. Okay, so first let's do S equals N minus A. Have 3 atoms. That's our N. Minus O on the periodic table. 3, 4, 5, 6. C, 4. And N, 5. Don't forget to add the charge of the anion. So this is 16. Sorry. 8. That means we have 8 electrons within the bond. Divide this by 2 and you have 4 lines bonding. 4 lines of bonding. So let's draw. Okay, let's just start with 1 each. Okay, so let's focus on this one first. Okay, so you know that carbon is supposed to have 4 valence electrons. And right now it has 2 because remember, since these are bonding, this is 2 electrons. 1 goes to nitrogen and 1 goes to carbon. Likewise, 1 goes to oxygen and 1 goes to carbon. So, what we need to do, let's just go ahead and draw 2 more lines. So now it has 4. So just fill up the molecule with the remainder. Okay, so for this following resonance structure, we're gonna look at this one and say, well, we can't do any double bonds anymore. So how about we take one of the bonds of the OC and transfer it to the CN. Let's go ahead and do that. So do we still have 4 valence electrons on carbon? Yes, we do. 1, 2, 3, 4. That's good. So now fill up the remainder. And for our third and last resonance structure, we can clearly see that since this is a single bond and this is a triple bond, we can easily just flip these and create the same thing but on the opposite sides. Okay, so for this resonance structure, oxygen needs 6 valence electrons. And it has 6. 1, 2, 3, 4, 5, 6. So its formal charge is 0. Carbon needs 4. And it has 4. 1, 2, 3, 4. So its formal charge is 0. And nitrogen needs 5. And it has 6. Whenever it has more than it should, it's a negative number. So 5 minus 6 is negative 1. In structure. Oxygen again needs 6, but it has 7. 1, 2, 3, 4, 5, 6, 7. So its formal charge is negative 1. Carbon needs 4 and has 4, so it's 0. And nitrogen has 5 and it needs 5, so it's 0. Again, oxygen needs 6 and it has 5. 1, 2, 3, 4, 5. So it's 1. Carbon needs 4 and it has 4. 1, 2, 3, 4. So it's 0. And nitrogen needs 5 and it has 7. 1, 2, 3, 4, 5, 6, 7. So its formal charge is negative 2. Okay, so very quickly, we're just going to eliminate this structure because it's the least favorable. It has too many units of formal charge and we don't want that. This one just has 1 and it has a negative charge on the oxygen atom, and this one just has 1. So we're just going to stay with these 2. So now that we have the 2 most favorable, this becomes the least favorable out of the 2 that are left because we eliminated the other one. So now we're going to look at the CO bond or OC, however you want to look at it. So for the most stable one, we have 1. So that's 1. If these two were equally stable, this is 2 and this is 1, it would be 1.5. And for the least stable, it's 2. Okay, and for the CN bond, for the most stable one, it's 3. For the equally stable one, if they were to be equally stable, this is 3 and this is 2, that's 5. Divided by 2, it's 2.5. And for the least stable one, it's 2. To predict the bond order for both of these, we're not going to look at the least stable one because this doesn't really depict what our structure should look like. Instead, we're going to use these. So we know that these values are not really included in what our bond order is. So we know that the CO bond should be greater than 1.1 and less than 1.4, because remember, this is not included. So this is what our bond order should look like. And for the CN bond, it should be greater than 2.6 and less than 2.9. Remember, these values are not necessarily included. That's why we use these instead.